Okay, we're going to start our new unit on quadratics. We're going to figure out what a quadratic function is, what the graphs look like, and what are some ways that we can figure that out. So here's a graph on the title page of a quadratic. You can see it's sort of a U-shaped kind of graph, but we'll get to more of those details in a minute. If you recall from grade 10, you guys studied linear functions. So linear function was a straight line. So that was an equation that looked like y equals mx plus b. So remember, m was our slope and b was the y-intercept. And then we could figure out x and y-intercepts by plugging in zeros. So looking at this graph that's on this picture, we can see our slope is, we'd go rise over run. So for this one, we got a rise of 3 and a run of 6. So that would give us a slope of a half. And we can see our y-intercept is at 5. So just from that alone, we know that this equation then would be 1/2 x plus 5. And the only other thing I have on here is to try to find the x-intercept. So from the equation, we could plug a 0 in for x, so we'd get y equals 5, so that's our y-intercept. Or we could plug a 0 in for y, so we'd have 0 equals 1/2 x plus 5, bring the 5 to the other side, times by 2, so we get -10 would equal x. And you can see from the picture, that is the correct x-intercept. So x and y-intercept's pretty easy to solve for. Just plug a 0 in for either one, and if we know the slope, from that we could draw a graph. So for any kind of equation, if I told you that we had an x-intercept of -2, and we had a y-intercept of 5, from that we could see that our graph would be something like that, and we could do a rise and run of 5/2, so we'd have a slope of 5/2, or 2.5 if we wanted to. So linear graphs, pretty straightforward. You guys did lots of these in grade 10. So what we're going to look at now is doing the same type of thing, except we're going to look at quadratics. So what made a linear function linear was we had to have an equation that had just a degree of 1 on the x. That meant we had something like y equals x, or 2x plus 3, or something like that. The key is the exponent had to be just a 1 on the x. Quadratics now are when we get x squareds. So your equation will be y equals x squared, or y equals x squared minus 2, or we could have 4x squared minus 2, or whatever. As long as we get an x squared in the graph, that's going to give us a quadratic. And if we look at our basic, just y equals x squared, you can see we get a U-shaped kind of curve like this. And the reason why it's curvy, if we kind of look at some coordinates, we have x of 0, and we plug 0 into x squared, so 0 times 0 is still 0. We put in 1, 1 times 1 is 1, so you can see we get sort of this, almost a straight line at the bottom. We put in a 2, that gives us 4. Put in a 3, 3 squared is 9, 4 squared would be 16, and so on. So you can see it gets steeper and steeper because we're squaring that number. So that's why we get sort of a curved shape instead of a straight line. And the other side, the negative side, if we do -1, -1 squared is also 1, -2 squared is also 4, -3 squared is 9, -4 squared is positive 16. So all of these negatives, because we're squaring them, they end up being the exact same coordinate in the y direction. So we end up getting sort of a mirror image on the negative side. It's just a curve upwards, but going the other direction. So what we need to do then is figure out what our equation is for a quadratic. So the standard equation we're going to use to describe a quadratic looks a little more confusing than linear. But once you break it down, it's not so bad. So our equation is y equals ax minus p squared plus q. So a in the equation, the a part, is just like we had for slope. So if you had y equals x squared again, it was just a regular line like that. If we change it to y equals 2x squared, what we're going to get is sort of a steeper or skinnier graph. If we change it to something like y equals 1/2 x squared, we're going to get something that goes a little bit wider. So the a is kind of like slope, but it's more of a, when you look at it, you see the U-shaped graph kind of skinnier or wider. And our PQ is going to be where the vertex is. So we're going to call the bottom part of the graph, so when we get a parabola shape, so it doesn't matter what kind of quadratic it is, that tip of the graph we're going to say is our vertex. So that'll give us our maximum or our minimum point. And the P and Q are going to actually tell us where that thing is located. So let's go through a couple of definitions that you need to be aware of. So the first thing is when we see a quadratic graph that's sort of U-shaped. So it's U-shaped, but we also call it a parabola. or we would say it's a parabolic curve. So that's just the name that we use for that sort of shape of curve. And we know that it's symmetrical because of the way when we get the same answer, whether it's positive or negative, when we square it, what we end up getting is a line of symmetry down the middle of that graph. So we call that an axis of symmetry, a vertical axis of symmetry. And we can use that to help us figure out certain coordinates. So if I told you that this coordinate was 3 spaces over from the line of symmetry, then we'd have to have another matching one 3 spaces over the other direction. So the symmetry sometimes helps you figure out coordinates, and the last part, the vertex, will help us tell us whether it's a max or a min. So if you look at a graph where our vertex is at the bottom, then we'd say it's a minimum. If we look at a graph where our vertex is up at the top, then we'd say that's a maximum. And the line of symmetry will always pass through that vertex. You talked a little bit about domain and range in Math 10, so we'll continue with that. So when we did linear graphs, let's just quickly review it. If you have a straight line that goes on and on forever in both directions, we said our domain was any real number for x's, and our range was any real number for y. So we just wrote xer, yer. So now with quadratics, it still goes on and on forever in both directions in the y direction. So we say our domain is still xer, it can be any real number, but now our y direction is different because we're stopping at a certain point. So we go from our minimum, in this case, all the way up. So we'd write that one, let's suppose that was at, say, -2. We would say our range then would be y is greater than or equal to -2. And if our graph was upside down, if I drew a graph that was something like that, and that maximum was, say, at 3, we would say our range is y is less than or equal to +3. So our range will have to do with where that vertex is located. But other than that, it's very similar to linear graphs. So now let's figure out what each of these numbers actually do. So our a value in our equation, so we call those a, p, and q parameters. We change those things depending on the graph. First thing we want to be aware of is what happens if that a value is negative. So if we look at a graph that was y equals x squared, that's just our regular U-shaped graph upwards. So if we type in y equals -x squared on your calculator, you would get the exact same graph but upside down. So we call that negative out front a vertical reflection. So if the a is positive, it's upwards. If it's negative, it's opening downwards. Then if we put a number in front, like 2 or 3 or whatever, what that's going to do is times that y coordinate by that amount. So once again, if we look at y equals x squared, we know that the coordinate was at 0, 0, 1, 1, 2, 4, and so on. So if I gave you y equals 3x squared, what we're going to do is times those y coordinates by 3. So our 0, 0 would still be the same because 0 times 3 stays the same. 1, 1 would now be 1, 3. So it's going to move up quite a bit taller. So we'd have 1, 3, and then 2, 4 would switch to 2, 12. We'd multiply that by 3. So what ends up happening, we end up getting a way steeper curve. We could do the same thing in the negative direction. So the 3 or a 2 or anything like that for an a value is just going to tell you how much we're timesing the y coordinates by. So a bigger number would be steeper, skinnier graph. A smaller number like a half, a quarter, whatever would make it shorter and it would look wider. The p and q now are going to tell us how that graph is moving over and up or down. So the p value is going to be our left and right. So if you graph y equals x plus 2 squared, so our regular y equals x squared again looks like that, we would think common sense would tell us that if we do plus 2, that we should probably move it 2 to the right, 2 to the positive direction. So we would think it would go over there, but if you actually graph this one, it doesn't, it goes to the left. So this graph would end up being a shift to the left. So the trick to this one is our sign in the equation, it actually ends up being opposite. So we have a plus 2, that means we're going 2 to the left. And that's why in our standard equation, we write it as a negative. So that negative tells you, make sure you do the opposite of whatever is there. And if it was a minus 2 in that case, then we'd be going 2 to the right. And our q is our vertical translation. It's going to go up or down. And that one we don't have to worry about it. So if I put on y equals x squared plus 5, so we're just going to take our regular x squared graph, but now we're going to move it up 5. So it would be a vertical shift upwards. So the Q is normal, it's just the P that you got to be careful of that's going backwards. So let's do some practice graphs here, and you can type these in on your calculator and double check, but we can usually get the idea of what's going on. So our red graph that's on here is y equals x squared. So it's good to have a standard graph all the time that we can compare things to. So let's go through these 10. So the first one we got y equals 4x squared. So that just means we're going to times everything 4 times bigger. So let's look at our coordinate again. So 1, 1 is now going to move to 1, 4. 4 times 1 would be 4. So we're going to go up to 4. If we have 2, 4, the original one, it's going to jump up to 2 and 16. So it's way off the grid. So you can see already just from that we get a lot skinnier graph. So it'll look kind of the same, but 4 times taller, so it ends up looking skinnier. If we do the next one is negative a half x squared. So that means our first thing we're going to do is flip this thing upside down. So let me kind of sketch that first. So it would be our U-shaped graph going upside down. But now we're going to take those y coordinates and make them half as tall. So the 1, 1 would go to a half. Same thing in the negative direction. Our 2, 4 is going to go down to 2, 2. Same thing in the negative direction. So we get sort of a wider curve, something like that. Okay, we'll clear those off and let's move on to the next couple. Oops, that didn't work. And I lost my page. Just hang on one second. Okay, I accidentally cleared my graph and my equations, but that's okay. We'll just do them by hand here for the rest of the way. So I'll just resketch our basic graph. So our y equals x squared was our U shape, something like that. So let's just do a few different ones. They may or may not be the same as what we had before, but that's okay. So if I give you the equation y equals, let's do x plus 2 squared. So remember that plus 2, that's our p. So if it's plus 2 means we got to do opposites. We got to go 2 to the right. So we're going to get our U-shaped graph shifted over 2 to the right. So let's try a different one. Here, I'll do a different color for this one. So let's try y equals negative x minus 3 squared plus 2. So remember the negative is going to make it go upside down. The minus 3 is going to move our vertex 3 to the right. And the 2 is going to go 2 up. So our vertex would go over 3 up 2, and the negative is going to make it go upside down. So it would look something like that. Let's try a couple more. So if I gave you y equals 1/2 x plus 4 squared minus 1. So once again, the plus 4 means we're going to go 4 to the right, or 4 to the left, sorry, and 1 down. So that would be our vertex. And the half is going to make it half as tall. So we'd end up getting sort of a U shape, something like that one. So you get the idea. These equations, pretty straightforward. We just want to change the A value to make it wider, skinnier. The negative makes it go up or down. And then our P and Q numbers tell us where our vertex is located. So let's maybe do one more. So I'll pick a different color here. So let's do y equals negative 4 x minus 3. Let's do x plus 3 squared minus 2. So once again, our vertex is going to be at minus 3 minus 2. So it's going to be down here somewhere. The negative means we're going to go upside down, and the 4 means it's going to be 4 times taller, so it's going to be pretty skinny, upside down, something like that. And that's good enough for today.